everybody, it's Eugene Liscio here, and welcome to Forensics Talks. This is the big one, the big 5-0 for me, 50th episode, so pretty happy about that. It's been a heck of a run, and hopefully I'm going to continue to keep going here. A couple of things before we start. As always, I love to know where people are from, so make sure that you just go ahead, say hello in the chat window, and let me know where you're from. I always like to, understand where people are watching from, if they're from overseas or whatever. So by all means, hopefully I'll see some comments in there coming soon. Today I am going to be sort of talking about 3D technologies. So I am on my own. This is going to be a little different for me. Normally I'm asking the questions, and today I have to imagine the questions, or perhaps answer some questions in the chat window here. So I'm going to do my best to manage all these screens at once. It's a little tricky when you're doing it by yourself, but no problem. So a couple of things that I wanted to cover before we sort of jump into the whole 3D thing, and that had to do with some announcements. Okay, so I'm just going to bring up some things on the screen here, and the first one has to do with the IAFSM conference. Now, since we're going to be talking about 3D technologies today, those of you who are interested in learning more, there is going to be the International Association of Forensic and Security Metrology Conference in Denver, February 14th to 18th, 2022. And that is in conjunction with the Association of Crime Scene Reconstruction. Now, a couple of things that are sort of important to note are, well, two in particular. One is that I'm actually teaching the basic laser scanner certification course. So this is a sort of an agnostic certification, so it's not any one manufacturer or anything like that. There are other guest speakers that come in and talk about different aspects of laser scanning and how it applies to crime and crash scene cases. So that would be pretty interesting. And that comprises a number of webinars that you watch before you get to the location, or before you get to Denver. On the Sunday before the conference starts, it's a full day of training. So it's a full 8 hours of lectures, exercises, math, software. There's a whole bunch of stuff, a whole mix of things that you can do. And then during the week, you have to attend a couple of workshops. And one of them in particular is really interesting. One is the mass shooting exercise, or I should say the mass casualty exercise that's going to be at one of the arenas in Denver. And so this is being really, really well organized, a lot of people involved, big event. So please keep that in mind. If in case you want to jump on that, let me just bring that up here. So it's just iafsm.org. Make sure you jump in on that and have a look. It may be very interesting for you. I realize travel can be a little bit complicated today, whatever, but hopefully let's hope this this virus thing just disappears pretty soon, because it's really annoying. So it's interfering with everybody. So hopefully you'll be able to get there. Now, the second thing that I want to bring up is something that I've been working on, which is the Forensic Photography Symposium. And so that is going to be coming up this January 17th to 20th. And if you are working in identification, forensic identification, for documenting crash scenes or whatever it might be, if you're documenting evidence with a digital camera, this is going to be for you. We have one heck of a lineup, and I've been really excited because of the response that I've been getting, and people have been signing up. We have a full abstracts are closed, so we have a full schedule already. In fact, I just posted a brand new schedule today, so there's some new ones that are up. So make sure you go to the schedule page and check it out. The website is just here. Okay, so it's just my website, ai2-3d.com/fps, and have a look. And look at the kinds of things you are. The way it's going to be set up is 4 days. The majority of the presentations are from 1 p.m. to 5 p.m. However, I've added some morning sessions. So on the Tuesday, there's a networking session, everybody to come together and just chat in different breakout rooms, vendors, and things like that. And then on the Wednesday and Thursday, there are what I'm calling the rapid fire sessions. So these are going to be a lot of smaller talks, very dedicated topics like work, how can you do a certain thing in Photoshop, or how could you do something with your camera here? So a number of different topics, and it allows us to bring in a lot more people and a lot more different topics. Now, a couple of questions that have come up with respect to the Symposium, it is being recorded. Okay, so every single day is going to be recorded, and I'm going to try and do my best at the end of the day, at the end of each day, I will try to make the recordings available. It takes a couple of hours to process or whatever, but as soon as it's processed, I'm going to fire off an email to all the attendees so that they can watch it. And in fact, we have some people who are going to be attending entirely remotely, or watching the recordings, I should say, because they just can't attend, or it's just an inconvenient time because they're over in Asia Pacific or whatever it might be. So if you have to miss a day or something like that, no problem. There are recordings that are available. Also, if you are a student and you're watching, by all means, there is an educational discount. So when you go to the registration, let me see if I can pop into the page here and I'll just show you. Go down the registration. You'll see here it says regular registration and educational. So if you are a full-time student, fill out the form, send us proof of your status, and then we will get that approved right away, and that comes right to us. If there are, somebody did ask about the payment. So I am using PayPal, but when you do go to PayPal, at the very bottom, there's a button there that says you can pay with credit card. You don't need a PayPal account or anything like that, debit or credit card, and that'd be fine too. So hopefully that's not a problem. If anyone wants to register large groups of people, 10 or more, then you can always contact me. And all you have to do is here, just go to this particular email that's down here, just fps@ai2-3d.com, and we will take care of you personally. Okay, no problem at all. Any inquiries or anything else, just send it to that email address and we'll be fine. Okay, cool. Well, let's get started here. And I am going to remove this. And so, well, like I said before, this is the 50th episode, which I was thinking about, and well, that can be quite a bit. 50 of anything. Try eating 50 cookies or 50 packages of chips or something like that. That can be quite a bit. So I'm happy that I've gotten this far. And I do want to say thank you to really all the speakers and all the people who have given us their time and shared their knowledge, because it's been fantastic for me. And if you want to know the basic story of how this started, I thought, you know what, I'll do something related to my work, which is 3D. And so I thought, hey, I can present on 3D and do all kinds of stuff. Well, it took me about 2 minutes to realize that was going to be boring as heck after. So I said, it'd be so much more interesting if we talk about different aspects of forensics. And I can tell you from my side anyway, I've met people who I never knew before, and they've done some amazing work, really fascinating stuff. It's really expanded sort of my understanding of all the different fields and disciplines in forensics, and many of the different issues also, which are common to many of us as well. So I hope you've enjoyed it. I don't know how many you've caught. They are all on the YouTube channel. And another thing, I've been asked before, like, why don't you ask people to ever subscribe or like hit the button or whatever? And I don't know. I just, I always feel like it's like telling somebody to put their seatbelt on in a car. It's like, do you have to tell people to do that? I don't know. Maybe I do. So if you want to subscribe, go ahead. But I prefer not to harass people about that. Okay, let me just set up here quickly. In fact, what I'm going to do is just have a quick look at the comments before I do that. Hey, Jason, Erdem, welcome. Look at that, all the way from Turkey. Amazing. We got Texas. It's Ryan. Excellent. Wonderful. So thanks, everyone. I appreciate you guys being here. Okay, let me get into this. And I need to, I'm going to share my screen. So because I am on my own today, I am going to add some slides to sort of enhance what it is that I'm speaking about. And so I apologize if this comes across a little bit like a lecture. I'm going to try not to do too much sort of like lecturing, but I am just going to speak on some of the slides, and I'll be sharing my screen. So let me just take care of that right away. And I believe that's right over here. And let me get that going. Sorry. I just got to make sure that's taken care of. Beautiful. Okay. I hope that people can see this right here. So hopefully people can see that. And I think everybody can hear me and see me okay. If you can, if you got any problem, just let me know. Otherwise, I'm just going to continue on. So the topic for today and what I would like to discuss are 3D technologies and the role that they play in forensics. And I've tried to pare this down to sort of the most important items that come across in, for many different disciplines, whether you're doing crime scene or crash scene investigation, whether you're in anthropology, whatever your background might be. If you're using 3D technologies for whatever purpose, hopefully this will cover most of what you're interested in. So one thing I've never had to do was sort of make my own introduction here. So let me just go back and I'll just very briefly talk about who I am and what I've been doing just quickly. My background is in aerospace engineering, and I'm a registered professional engineer here in Ontario, Canada. Now, obviously, I've made a career change, and that was back in 2005. And I just had a great interest in 3D technologies, and they are technologies that are used in the aerospace industry to align, the aircraft with jigs and fixtures and things like that. And so that was my first sort of introduction to some of the 3D technology. But early on, even in university, using AutoCAD and other types of 3D modeling programs is very common, and so it's pretty much a standard today. So I had an early introduction to it. I really enjoyed it, and made the switch in 2005 to work on my own. I'm also an adjunct professor at the University of Toronto, Mississauga, where I teach a course. I had my last lecture yesterday for the semester, and it's an introduction to 3D mapping and reconstruction. And so the students there get to tackle a lot of different problems using 3D technologies and apply them to whether it's like bloodstain pattern analysis or shooting reconstructions or suspect height analysis. We just cover a whole bunch of different things, and they tackle these problems. One of the benefits of being at the university means that there are a lot of eager students, and I want to thank all the students out there that have worked with me and that are working with me right now, because they're very dedicated and they're working really hard to to get their research going and to publish. And so we have a number of publications that we've pushed out, which I'm really proud about. Really happy for the students because they get their name on something and it helps them with their CV. Also training, that's something that I do regularly. And of course, with this whole COVID situation, it's something that I've done a lot of since 2 years ago, since 2020. So teaching in many different aspects. So 3D technologies, a whole bunch of different things. So look for some of the courses. If you're interested, you can sign up. There are some sort of registration things, or if you're interested, the best thing to do is just sign up on the website on the contact form. And then as we have courses coming up, we sort of do like an email blast and just let everybody know, hey, we got this course coming up. And then if you're interested, you can always sign in. Another result of COVID has been a lot of this online stuff. So this is one of the things, this forensics talks, as well as Click 3D. So if you're interested in more sort of specific items, if you go to my playlist, which is Click 3D on YouTube, it's just look for 3D forensics. You'll be able to find a number of videos on laser scanning, on photogrammetry, on interviews with some really some really interesting people that are doing some really cool stuff and bringing new technology to the forefront. So you're more than welcome to have a look at that. I see that Erdem has no. So the university course is not available online. Erdem, it's actually it's through the university itself. So only students that register, that attend the university, they're fourth-year students, they're undergraduate students, and so that course is pretty much set up for them. Okay, well, what I'm going to be talking about is this area called 3D forensics. And so the first thing that I always try to explain to everybody is, well, what the heck, what the heck is this? What is 3D forensics? And it's really nothing more than the use of three-dimensional technologies that are going to assist with documentation, analysis, and visualization of evidence. And that package there, no matter what area you're working in, forensics, documentation, analysis, and visualization, is sort of the package of what you do. And so the documentation part is the technology that we use to, capture the evidence or the scene or whatever it might be. And then the analysis part, which is very, very important, and a part that I've really tried to focus on, which is trying to extract information from that data. And then finally, the visualization, which is the presentation of the scene or of your analysis. And so I'm going to be framing this talk today, or sort of this discussion, this way. So we'll be talking about the documentation, the analysis, and the visualization of evidence. Now, just a few weeks ago, I had to testify at a trial, and it was interesting because you get asked what are we qualifying you as? And so that's always an interesting question which comes up. So I sort of invented my own role. And so I call it a 3D forensic analyst. And that's what I call myself. And the reason is that I use a lot of 3D tools. And if I'm not using a laser scanner or photogrammetry or a structured light scanner, maybe I'm modeling something in 3D to learn something about it. And even when the measurements are by hand or whatever, it's always nice to translate them into 3D somehow so that they're visual and that they're easier to interpret. So, a 3D forensic analyst is somebody that works with 3D technologies. They provide analysis in different areas of forensics. So it could be for shooting reconstructions, it could be for anthropology, it could be for things like impression evidence or even BPA. And even though I may not be an expert in that particular area, some of the techniques and some of the things that you can do in 3D will help support experts in other areas. Okay, so even though you don't have that expertise, you can always help somebody else. And the last thing is, of course, that you need to be able to provide different types of visual outputs. So different types of reports, different types of deliverables, whatever they might be. And I'll be discussing some of those closer to the end when I get into the visualization section. Now, imagine that you are an investigator and you run into a situation that is something like this. You've got a crime scene where all of a sudden, you've got a body in a forest or something like that, and it's your job to go out and document it. Well, it's not bad if you're sort of in an open area and the evidence is kind of on its own and there's nothing around or whatever. That's sort of one scenario, but this is the type of scenario that forensic investigators may often find themselves in. Something in a forest, it's cluttered, and if you need to document something like this by hand, taking measurements and things like that, it becomes an extremely arduous task, and you need extra people, you need extra equipment, and it's limited on what you can do. There are things in your way, things are not level, the ground is not level, it's uneven. So there are many, many problems with something like that. Take the image on the right here where you have a mass pileup of cars, or you have a very serious accident that spans quite a way. They're not always that simple to document by hand. You don't just take measuring wheel out and then all of a sudden start measuring. There's a limit on what you can do. And this is a really important point when we start talking about 3D technologies, because 3D technologies takes some of that difficulty, some of those complex scenes or scenarios, and helps to simplify it. And I think that's one of the super valuable points when it comes to 3D technologies. Now, here I've got two scenes, but when we talk about documenting a scene or even evidence, that evidence can be big and it can be small. So here we have, for example, a firing pin impression on a cartridge case, and you can get in really close to really get some of these details. And in fact, many of the systems that are out there today doing comparisons and things like that, they will run fully in 3D. And so there are some dedicated systems that have different ways of recovering the 3D technology, but nonetheless, it's three-dimensional in form, which is really, really important. Now, if we swing to the other side of the spectrum, on a large evidence or something like that, well, it's kind of the same. We can go to scenes which are absolutely massive. So if you have natural disasters, if you have really big scenes where something has been occurring on multiple different places, you can document all of this. And this is a big point cloud that was rendered out in Clouds to Max. Now, there's another aspect of 3D evidence or 3D technology, and that aspect has to do with keeping evidence true to form. And it may be something that I haven't brought to light a lot, but I've been starting to more and more. And the fact is that when we take a picture of something like this, like a boot or a shoe or even a body, it's curved. It's a curved surface. It has a lot of depth. We're not just photographing a flat wall. And so as a result, when we 3D scan something, we capture the true form of the object, or at least we represent it quite accurately. I think that's probably a better way to say it. So we're not just looking at a flat image, we are looking at a 3D representation, which is true to form. And I think that's a super important point when it comes to 3D technologies. Okay, let's briefly touch on some of the documentation. So that's what I'm going to get into now. And let me just check the chat window. And get a sip here. Okay, looks like we're all good here. No questions or anything. So there are a number of different types of technologies that you can use to document. And so, I showed, for example, some of the cartridge case, firing pin impressions and things like that. So these are using fairly dedicated piece of equipment. So I'm not going to talk about 3D microscopes or micro CT scanning, but do know that there are other types of 3D technologies out there that can be useful in forensic investigations. The ones that I'm probably going to stick with are going to be hand scanners, like structured light scanners, and then photogrammetry, and then the laser scanner. So those are the three that I'm going to talk about mostly. So when it comes to structured light scanners, these are very common nowadays. There's many different types out there, many different manufacturers, new ones that are coming on, on the scene, and you have a wide variety of options. So trying to decide which one is right for you depends on what you're trying to do, maybe what area you're working in. If you're working in collision investigation and you want to document crash or crush, let's say, or something like that, whether you're working on a bloodstain pattern analysis project or something like that, it will matter. And these all vary in terms of their accuracy, in terms of their speed, and in terms of their output, like what kind of things that they actually will output for you, and even in terms of the software. So how comprehensive the software is may be important to you as well. So here I have three different types, and this is the Faro Freestyle II, this is the Artec Leo, and this is a dot product scanner. And all three of these are structured light scanners. And structured light really just means that you're doing something to the light, providing it with some kind of a structure or some kind of a pattern, and you're going to interpret that pattern when it goes over an object and distorts. And that distortion of the pattern will tell the system or the scanner that there's a 3D point at some depth or some distance away from the device. Now, in the case of the Freestyle here, you have basically two infrared cameras, okay, on the outside. So basically it sees like a human, two eyes. And at the bottom here, you have an infrared projector. So it's going to emit a pattern at the bottom. You're going to see it with two eyes at the top. And you have a third eye that's up here, and that is a color camera. And the color camera is used for two purposes. It's used for tracking so that the hand scanner knows where it is in 3D space. And that's a very common aspect between hand scanners, is that they will constantly monitor where they are in space, in 3D space. And the color camera is also used, of course, to color the data. So if it captures color, it can apply the RGB color that it collects to the XYZ data point. And so that's an important thing. And what does the pattern look like? Well, if you're interested, this is the Freestyle II. This is just a mock scene that I've done here in the office. But you can see the points. You can see them flashing. And you can also see that they have sort of a grid-like structure, but there's also larger points and smaller points. And so this helps to recover data under different circumstances, but you can see you just sort of pass it around the object or the piece of evidence, whatever it might be, and then you can recover 3D data. So something like this. Now this scan, one of the benefits, or another benefit of hand scanning, is that it's typically fast. And something like this took maybe 60 seconds or, maximum like 2 minutes to document. And then you process it in software and you have, in this case, a point cloud, which is fairly accurate. So a really nice use of this particular scanner. This particular one, the Freestyle II, is better for somewhat larger areas. Okay, so if you want to get on the order of 10, 15 meters, if you want to do a whole room or like a bedroom or scene or something like that, absolutely possible to do that with this particular scanner. Now, another type of structured light scanner is the dot product scanner. And so, and again, I'm just naming these because they are very common, and there are so many other types. I could have picked any others, and many of them would work in a similar fashion. So the dot product is really taking the structured, or these little sensors, okay, and these are like Intel. You can buy these from Intel. They are a few $100s, and basically you can plug this into your phone, or you can plug it into a tablet, a Windows-based tablet, Android, whatever, and you end up with a scanner, and it's for a relatively low cost. So it does a pretty good job, and you can see here, this is an infrared laser, which gets broken up. So if you look at the chair here, you'll see that there's a pattern on the seat and on the back here, and that pattern, it distorts over the chair and is what the system uses to recover 3D data. Now, this is color as well, and there's a whole family of these particular sensors, but this particular one, which is the 455, you can use these even outside, which is great. So indoor use, outdoor use, and you just have to look at the type of sensor that you have. Now, this isn't a little example that I did. This was a bloodstain impact that I did an analysis on, and this was using the dot product scanner. So, this is like 30 seconds of capture. Now, you'll notice that the data isn't as crisp, right? So, but that's the difference you get in terms of accuracy and cost. It's sort of the trade-off. However, I will say this, what dot product is doing in their software with this low-cost sensor is pretty incredible what they can do. And the software is actually really well laid out as well. It's a really great option for people that want to get an introduction to laser scanning. So yeah, if you want to check something like that out, it's a really great option, and it can be used for different types of analysis or just for general documentation. Okay, let's talk about photogrammetry. Now, photogrammetry is a hot topic, and it has been for a few years now. And part of the reason for that has to do with drones. And so as drones kicked off and we were able to take a camera and put it up in the air in positions that were at elevations that were just impossible to do with a pole or something like that, the level of control that you have on a drone is really incredible. And they're so easy to fly nowadays. It's really incredible. So that has definitely helped push photogrammetry forward. And so photogrammetry really just means it's a portmanteau of three words: photos meaning light, gramma meaning to draw, and metron meaning to measure. So a light drawing just means a photograph, and you measure from a photograph. And most people, I think, today know that if you take a lot of images of something and then you upload it into software, you spit out a model. It'll spit out a 3D model. It can be a textured 3D model. You can export the point cloud or just the mesh in the case you want to like do 3D printing or something like that. But the general process is highly automated today, and not like it was back in 2005 when I started, which was fairly manual. There was still a lot of I would say it was semi-automated. That's probably the best way to say it. There was some automation, but certainly not like today. Today, there's been a lot of advances that make it a lot simpler. So photogrammetry, I think, is an excellent technology, not just for drones, but for crime scene or crash scene documentation. And part of the reason is that it's an extremely flexible tool. It's low cost, and anyone that can afford a mobile phone already has a camera built in to the device. And so it's the technology that's required is fairly readily available and low cost. There are free options available on the internet. One that's been getting a lot of attention now, I think it's called Mushroom, I believe is what it's called. But you can see here the level of detail and the way you can mix up photographs and to get an overall and a very close or very close-up models with details is really helpful. Now you can also use video. And so this is an old example that I just keep showing over and over because it just makes a lot of sense. You can do it today, but even with an old camera, phone, you take a video of something like this, and then you extract the individual frames, and eventually you end up with a 3D model. And by today's standards, using a more modern phone with 4K video, 60 frames per second or something like that, we can do a lot more today with video and photogrammetry. So it's a great way to document something quickly. And the benefit you have of video is that you always have overlap in your photos because the individual frames are capturing at such a high rate that you can extract every single one or every 10th one or every 60th one, whatever it is. So it gives you a lot of flexibility that way. Now, the downside of video, especially when there are things like rolling shutters and stuff like that, is that if you're moving really fast or there's a lot of motion or movement, then you start introducing blur and you start getting other types of artifacts from the shutter. But if you're moving relatively slow or you're capturing at a higher frame rate. So in fact, the video, I didn't mention this, the video that I captured there just before was at 120 frames a second. And so by doing that, as I'm close and as I'm moving, the individual frames are nice and crisp. There's very little blur. So it's just a little trick you can use in some situations. Now, sort of the flexibility of photogrammetry, which is fantastic, is the fact that you can do little things and you can do big things, right? So if you've got a big disaster, if you've got a building that's come down, if you've got a massive fire or whatever it might be, you take the drone, you fly it, and then you can produce a 3D model. And so something like this, which I never stepped foot in, but did, we did a flight just across the street, captured all the photos, and it allows you to take a model like this, put it into virtual reality, and you can sit there or stand there right at the bottom and then kind of look at all the mess that's there without ever having stepped foot in that particular area. So great for, places where are difficult to get in or where you have to capture a very wide range or large scene. The drones have really, really helped there, and photogrammetry has been great. So let's talk about the laser scanner. And the laser scanner has really, really transformed forensic investigations, that's for sure, in so many different ways. Things like shooting scenes, bloodstain pattern analysis, crash, documenting crash scenes. It has a lot of benefits. And there are still, if you think about the predecessor of the laser scanner, which was the total station is still a great, great instrument. Nothing against the total station. It has its benefits. So for example, if you have a very long straight stretch of roadway, the total station does a really good job there. That's one of its strengths. It doesn't have to make these little jumps in between positions or whatever. So, and you can combine a laser scanner and a total station and work with them together too, to maximize or sort of benefit from the strengths that each of those instruments has. So there's plenty to do and talk about there, but let's just talk about the laser scanner. As many of you know, this concept that I talked about before, like this true to form, when you look at a video like this, you're not guessing like a total station what all the points mean. Is that the curb? Was that the corner of the curb? You're looking at millions and millions of densely packed points, and those points are easy to interpret. So whether, it doesn't matter if you haven't used a laser scanner before, no matter who I show this to, they can see the road lines, they can see the vehicles, they can see the separation, they get a sense of the space. And that's because it's true to form. And that goes back to the concept that I was talking about before. Now, there are other reasons for using a laser scanner. And if you were to take this little example, again, this is an old example, but it still makes the point for me and hopefully for others as well. 3 bedrooms, a little hallway here, and I've cut off the ceiling here so that you can somewhat see inside. And this was 9 scans, 11.5 minutes. So if you had to take measurements of this by hand, or even if you had to use it, try to do photogrammetry or something like that, it would be next to impossible to capture this much data in as little time. You have millions and millions and millions of points here. So if you are required to go fast, so let's say, for example, you're outside and you have a crash scene and you want to be able to document this crash scene very fast, the scanner allows you to do that. Right? You can change the settings to move quickly. And now that may mean that, I just want, plain data. I want more coarse data. I don't want to capture as much data. But if you compare that to a total station, for example, if you were to take 1,000 points, 1,500 points on a total station, you're there for a long time. Okay. And sometimes it's a 1 or 2 person operation, but it's going to take you some time and you're still not going to be able to get this much data. Now, the laser scanner is basically like a laser pointer that's spinning around. And so this is my old laser scanner, but the nice part is that it's working at a wavelength of 905 nanometers. So my full spectrum camera can pick up the beam as it's swinging by here. So hopefully you can see this and it's playing okay over the internet. The thing here is that as it sweeps by, you basically, there's a signal that comes back to the scanner. And even though the mirror is moving really, really fast, light moves even faster. And so you can pick up a ton of data this way. And you get this 360 sweep of the environment. And the other real benefit of the laser scanner is that it works super, super well in complex environments. Okay, so the more complex the environment, the greater the benefit of the laser scanner. So you take a forested area like this, and I was kind of alluding to this at the very beginning. What could you do here with just a string, a tape measure, and a few people? Well, you could probably get general measurements, but you certainly couldn't get anything like this. So the laser scanner is the only instrument of its kind and the only instrument that will capture this much data in little time. Now, there's some things we have to consider when it comes to using these types of technologies at court or at trial. And of course, laser scanner accuracy is a big deal. So, you want to know, does this thing work? How accurate is it? What can I use it for? And so there are a number of studies that have been done out there today from different people. And here's one that I did with myself and my colleague, David Dustin. And this was just a 60-meter underground parking lot. So a controlled environment, and looking to see what kind of accuracies we can obtain. And so this was compared to a laser tracker. A laser tracker is a highly accurate instrument, at least one order of magnitude more accurate than the laser scanner, if not 2 orders of magnitude. And basically what we found here, without getting into the numbers, is that the accuracies are down to a few millimeters. And that's good news. Okay, whenever we can get down to a few millimeters, and when I say that, I don't mean just with single scans. I mean when you register with targets, or when you register with targetless or cloud to cloud, you have some really good accuracies in both ways. They were very, very similar, and so was the repeatability. Very, very small repeatability, which is great to know. If you are interested, let me just put this into the chat window, but I actually just did a video on laser scanner accuracy. And if you're interested after here, you can always go check it out on YouTube. I just punched it in there, and hopefully you can check it out, and I hope it will be informative to you. Now, let's talk about, those are the 3 types. So I talked about structured light scanners, photogrammetry, and laser scanners. There are others, but those are the main 3, I think, which are most common when we talk about crime and crash scene documentation. So let's move on to analysis. So this is where we're going to do things to the data, combine and compare, interpolate, reconstruct, do a whole bunch of different things. And I'm going to quickly breeze through this, but it's just to give you some idea of the kinds of things that can be done. So deviation analysis is a way of comparing point clouds. And if everybody knows Cloud Compare, I teach courses on it. It's a fantastic program. If you can get it for free. So look at Cloud Compare online, and let me just type in the name of the software here. If you do a search for Cloud Compare, it will pop up in Google for sure. But the idea here is that if I took an impression in sand or something like that, and then I have a suspect shoe and I put them together, what can it tell me about the differences or the similarities between the impression and the shoe? And so something like this is where we can make a comparison, and it's a different paradigm than what is being done today. So it's not just looking at photographs and then saying, hey, there's a feature here, and there's a feature here, there's a feature here, and a feature here. They look similar, whatever. This is actually giving you a statistical breakdown of how close or how different all of the points are. So completely different paradigm here, and an interesting new way of analyzing impression. Also bullet impact. So when you have a ricochet in metal or something like this, there are ways to collect this type of data now using photogrammetry or a small structured light scanner, and then look at it a little bit more closely and do different types of analysis, maybe to get a better result on the impact angle or the exit angle, the ricochet angle. There's been some posts online recently that I've seen from one of my friends, John Paolucci, and he's doing some pretty cool stuff in that area. But just to give you an idea of some of the things you can do. Continuing on the theme of trajectory analysis and shooting documentation or shooting reconstructions, the laser scanner has absolutely transformed this whole area in the fact that it can take a whole number of different trajectories and combine them all into the overall scene. And so this is something that's very difficult to do. It's, you can take manual measurements with a trajectory rod and measure angles and things like this. But even when you're going around a car, or what if you're going from outdoors to indoor or 2 rooms over, it becomes a little bit more complicated. It's not something where you just pull a string or shine a laser and it gives you everything that you need. It becomes a little bit complicated, but doing it with the laser scanner allows you to see things that were really not possible before. It'd be very difficult to model and see through 2 or 3 walls and watch the trajectory as it goes across. So I have some cases that had multiple, the same shot, but had multiple impact points. And so being able to trace the shot and the path of the shot was very, very useful. Now, when it comes to validation and presentation of this in court or at trial, it's really important that people focus on errors. And I'll say this sort of again, and that is that when you're doing research or when you're studying an area, it's not about whether or not it works. It's where does it fail, where does it break down, and what kind of confidence can I have in the errors that are associated with that method. And so that's something that I've been spending a lot of time on in different areas using the laser scanner. That's typically what I'm doing, trying to figure out where it breaks down or where it doesn't work, as opposed to where it does work. And without getting into the numbers, one of the benefits of using the laser scanner that has become obvious to me, well, there's a couple of things that it's shown. One is that if you compare the laser scanner to hand measurements, the good news is on average, the hand measurements and the laser scanner are very similar. They're very, very close together, which is good news. It means that, we're not doing anything sort of bad by taking hand measurements. The thing that is sort of bad or more positive on the laser scanner side is that one of the things that we see is that the variance of errors. So if you took repeated measurements, the range of errors is much smaller for the laser scanner. So we don't get the same kind of maximum errors that we do when you do it by hand. And so that is a benefit of using the laser scanner, is that it limits the maximum errors that you may encounter when compared to doing something by hand. So keep that in mind. And there are other areas. So for example, suspect height analysis. So recently we published a paper using Photo Modeler. There was another one that I did in 2015, I believe, which was using Ferrocene. They have a plugin where you can do a suspect height analysis here. So this idea of combining photographs or video and 3D scanner data is really important. And it's now becoming more and more relevant. There's other programs that are now doing the same thing, combining these two to get like speeds of vehicles from video and things like this. Bloodstain pattern analysis also. So this is an oldie. This is one that I did a really long time ago and I show it all the time. And I make the statement that this is probably the most complex area of origin analysis that I've seen. And I haven't seen any that have been more complicated than this. But the good news here is that you can do this with a laser scanner and software. And it's not because I know something, that's more than somebody else. It really has to do with the fact that the method lends itself to doing more complicated scenarios. It's the same as doing it on a flat wall or a very simple scenario. You're just doing it on something that appears a little more complicated. So it's more of the same thing. And it allows you to do some really, really complex scenarios. And this is, again, has been studied, bloodstain pattern analysis. There are a number of papers in this area that myself and students have published. And so long as you're aware of the type of impact that you're doing, you're not pushing the software beyond what it's meant to do, then you can get perfectly acceptable results that are in line with other software programs like Hemospat or Backtrack or Hemovision or whatever. So the benefits here are quite high. And of course, the other benefit is that it's visual, right? So when you're looking at these images that are on my screen, it's not just, numbers that you're looking at, but you can see the trajectory, the blood trajectory paths. You can see where they converge in space, and you can say something about it in the context of a crime scene. Now, the other thing that's I'm quite happy about is that recently, about a year ago, I did a study on cast-off patterns. And so I looked at sort of a way that grows off of the area of origin and then try to implement it using 3D tools to do or analyze cast-off patterns. And so this was pretty cool for me. I really enjoyed doing this paper, and this was the first paper, but there was a second paper that just got released just a few weeks ago. And this was an inter-observer study where inside of Ferrozone 3D, I had a number of people that analyzed a cast-off pattern. And what I was looking at was the deviation or the differences in error in their results, and what kind of variability do we get here. And the benefit was, or what I found here was that we only have about a plus or minus 15 centimeter variability on the width of this cast-off pattern. And so maybe that doesn't make a whole lot of sense right now, but let me see if I can explain. This is a colleague here in the Netherlands, and he's taking a couple of swings here. So he has a rod, and at the end of the rod are some, it's blood soaked. So as he swings, it causes a cast-off pattern on the wall. And he's being motion tracked. So you see he's wearing this uniform, and he's got like these armbands and things like that. So everything is being captured in 3D. And so I can take that 3D motion and I can apply it to a character model, and I can track all of the motion. So these blue lines that you're seeing is the tip of the rod and the path, the swing path. And then all those red lines that are coming off the wall is they're basically the analysis that was done in Ferrozone 3D. But if you just look at the paths and you look at the trajectories coming off the wall, there's another benefit to doing this in 3D. And that is that when I was doing this, the patterns that are being formed here by this motion and by this geometry are telling me something about the path and that sort of thing. And if you look at it here, you may be able to discover it for yourself. But this was something where just observation was really important. And in science, being a good observer is super important. And some of the greatest scientists in the world were just observing. They were fantastic observers. Leonardo da Vinci, Galileo, just very, very good observers. So let me move on here. So what came of this basically is something called a path volume envelope. So basically there's a way to enclose a box around the swing path, and that box, you can say something about the swing path was somewhere inside of that box. And there are ways to refine this even more. So the point here is that working in 3D has opened up new opportunities and new ways of analyzing things that were not done before. And there are still many, many opportunities and many things that can be done with 3D technologies going forward. Okay, let's talk about visualization here. And visualization is really about the presentation of the results. And in some cases, people will just document a crash scene and then just show you a video or an animation or something like that. And other times, you will take the data, you'll do some kind of an analysis, and then you'll show people what you have. So it's not just about showing the scene, it's also about introducing the results of the analysis. And that's an important part as well, so people understand what it is that you've done. And there's different types of visualization formats. So, 2D drawings are still quite common. Animations, I've shown you a whole bunch already, so I'm not going to show you it again, but also 3D printing, right? So this is just taking something very small, like a person's finger, and then bringing it up or making it larger, expanding it, zooming in on it. And here we have like a 3D, copy of a person's finger. And you can hear the ridges on this, which is pretty cool. So from a learning perspective, if you're a juror, being able to interpret something like this, or being able to hold it in your hand, you can color code these and then being able to say, hey, yeah, that makes sense. And oh, here's the suspect's print at the scene. And you look at the two. It's just another way for people to learn. And, the 3D print could be a weapon, it could be a bone, it could be whatever it might be. So 3D printing is another way that you can take these this 3D data and then visualize it somehow or provide it to somebody physically. Now, there's also these virtual tours. And so I just did a video the other day on virtual tours and how to use, in my case here, it's Scene2Go, but there's a whole bunch or a whole family of different products out there, even without the laser scanner. If you just want to take a 360 camera like a Ricoh Theta or like an Insta1X, and then use some virtual tour software, you can produce stuff like this. And you can see here, this particular software, you can even couple in or package in the photographs or video, lab reports, or whatever. And it allows you to look at it by taking measurements. You can look at the different intensity channels or things like this. So a lot of good use for this, because you can hand it to another investigator, you can hand it to a jury, and they can sort of move around and look and sort of understand what is going on in that particular scene. Virtual reality. So this is an important one. So virtual reality is there's a lot of hype about it these days, that's for sure. And I'm cautiously optimistic about it. And probably some of the people who are doing some of the best work in this area, I believe, is River. So reality and virtual reality. And so here they have like a training module that you can completely immerse yourself in. And just yesterday, I had a class, my last class, I had Alex Harvey from River talk about some of the work that they're doing. And he likes to distinguish between 3 degrees of freedom and 6 degrees of freedom. And so 6 degrees of freedom is where you're fully immersed. You can walk around, you can interact, move around, move your head around, move your body and everything else. Whereas 3 degrees of freedom is something like a virtual tour with a headset on. So you're sitting in a chair and you can just sort of turn your head around and look. And so there's different capabilities and aspects. Training is one. And they have something here. You know what? I'm going to get back to this in a second. But the other one is what I think is even more powerful is being able to capture the crime scene, doing your analysis, and then immersing yourself inside of the scene with the analysis. So here I have Dr. Uwe Vossner from the University of Stuttgart. And he's inside a cave. And so he's got these 3D tracking glasses on. And so what he's seeing is not what you're seeing here, but he's actually seeing the lines, the trajectory lines from these bloodstain patterns come out of the wall. And he's interacting with the results of my analysis. And so that I think is pretty cool, when you can also put in the results of your analysis and then have investigators or jurors or whatever visualize it as well. And that's a very, very powerful point. So what does the future hold? What does the future hold? Like what's next and everything else? Well, there's a whole bunch of things, and let's talk about it this way. There's documentation, there's analysis, and there's visualization. And those 3 things still become relevant in terms of the future. And of course, we know that there are different types of mapping technologies now. We're seeing now this Boston Dynamics spot. I call it the village bicycle because everybody's taken a ride already. This is every scanner manufacturer's been on this poor guy's back. So, but it's kind of interesting, the fact that, you know, autonomously it may be able to do some work, regular monitoring or scanning or whatever, and then interact with the environment. So that's kind of neat. Also on the right here, this is the NavVis system. And so there's a puck here on the bottom, and there's a LiDAR puck on the top as well. So it's scanning horizontally this way and then vertically this way. So as you walk with this, you're picking up a bunch of data. And let me see if I can zoom in on that just so you can see this a bit better. But I hope everybody can see there's cameras here as well. So there are like these wide angle cameras. So it creates a 360 image with the data. And it does this fairly quickly and provides you with a point cloud, and it provides you with a type of virtual tour as well. But obviously, if you're walking this and you're out at a crash scene, or even an outdoor crime scene, or even indoor, you can do this very, very quickly. Now, the accuracy isn't as high as a terrestrial scanner, but it is kind of interesting what they're doing here. Another thing that we're seeing is the integration of different types of sensors and different types of tracking and this sort of thing. So providing the unit with more intelligence. And I give credit to, I was really interested in the Leica RTC because of their Viz system. And so what they're doing here is that there's a number of cameras on the unit here and here. And if you pick up the unit and you walk with it, it's watching where you're going. It's tracking your movement from these multiple cameras. And I think that's pretty, ingenious. I think that's quite interesting, the fact that it's helping you to, or it's helping itself sort of navigate from one position to the next. So I think that's kind of cool, and providing it with more intelligence. Another one that I more recently looked at, which I think is quite interesting, has to do with the Artec. So Artec is a scanner that I showed at the earlier on in this in the presentation. But one of the things that they've done, which I think is super cool, actually 2 things they've done, which I'm going to talk about, which I think is pretty cool. One is that they have included some artificial intelligence, which enhances the scans. And I don't know the full technology behind this, but what I do know is that this is on their new scanner. But if you have one of their older scanners, which is the Artec EVA, even though it's a 7 or 8-year-old scanner, they're applying the artificial intelligence on the older scanner to get you more detail. And so I've experimented with this a little bit, and it does work. It does indeed give you more detail, and I think that's kind of neat, because now they've gone back. Something that a lot of manufacturers don't do is they're giving their scanners more life and extended life because it's still collecting good data. So I think that's kind of neat. The other thing that they're doing is that they're fusing technologies together. So they're taking photogrammetry and their laser scanning and combining it together to give you really, really high quality textures. And so Artec does a really good job in their software. It's a very comprehensive package. So this is a new feature. It just came out in their Artec Studio 16. But basically, if you scan an object, the scanner itself will collect color. But then you go back and you take a number of photographs. And when you take those photographs, what it does is it calculates all the camera positions. And then you can use those camera positions and those photographs to reapply the texture, or basically get a texture based on a nice digital SLR camera, or a good iPhone, or better lighting. I mean, the cameras which are on these scanners are not high end. They certainly can't compete with a decent digital camera. So this is kind of neat, this fusion of technologies, which is kind of cool. And this brings me to my next point, which is the iPhone LiDAR. And this is something that some of you may have seen that I did a video on a while back, and it's super, super interesting. And I'm very, very happy to announce that on my phone right here, there's a little icon here, and that is a beta version of software that I will be kicking out pretty soon. And it's called Recon 3D. And basically, when you hit it, you get this little, you can see my room here when I'm moving this around, but this is going to allow you to do something, which is scan with your phone. And this idea of sensor fusion is really quite interesting. And this is using the Everypoint engine. And so Everypoint's been online, they've been talking about what they're doing, but this is a scan that I did in about 60 seconds, walking around the car a few times, and it was produced with the iPhone. This was an iPhone 12. This is an iPhone 13. There's really no difference in the capabilities other than the power that's in the phone for processing. So I'm going to be, I'm hoping that in the next week or two, I'll probably be having a webinar just dedicated to this new app that's called Recon 3D. And I'm pretty excited about it, and what it can do for forensics, because if you can go out and you can if you scan something with a phone that's in your back pocket very quickly, that's pretty awesome. So it can do small things. Now we're starting small, but it could go bigger. So this is a parking lot that I did with the phone. It's not really intended for big things, but I have done up to 500 meters with the phone, and it seems to come together. So a couple of features that are on there. Well, I'm not going to get into it now. I've talked enough, but there are a number of features on there which I will get into hopefully in the next couple of weeks when I make the announcement, and I'll explain why this app is dedicated to forensics and how it's different than some of the other apps that are out there today. And just so people know, somebody had asked, the app is called Recon-3D. It's not available yet. It will be. Okay, it will be. It will be. It will be soon. All right. Other things that I think for the future are going to be really interesting, and that goes back right to the artificial intelligence. And so this is a point cloud, and this is something that is done today, which is segmentation. And so if we can look at scan data, and then we can look at photographs, and we can determine, hey, these are trees, these are poles, these are houses, and you can see there's like different colors here for different things, then there's perhaps other things that we can do for crime scenes. So maybe you put your placards or your evidence markers down, or maybe the artificial intelligence can figure out, what is crush on a vehicle, the extent of crush. They can figure out what is a blood stain versus a gun versus something else. There's a lot of little things I think that could potentially come up in the future. But yeah, even right now, the fact that we can take data like this and review it or analyze it. For example, there was a study that was done years ago where for fire investigation, for example, somebody was laser scanning a number of concrete blocks that were subjected to different elevations, temperature elevations. And so some that were difficult to see by eye how much they were exposed to. When you look at the intensity channel of the laser scanner, you could see there were differences. And so maybe that could give somebody a clue as to whether or not this building needs to come down or be repaired or whatever. So a whole bunch of different opportunities there going forward. I'm going to leave you with one quote here, and then I'm going to answer some questions in the chat window. But this is a great quote from Lord Kelvin, and I think it really says a lot about the status or sort of the state of the importance of 3D forensics and being able to get good data. He says, I often say that when you can measure what you're speaking about and express it in numbers, you know something about it. But when you cannot measure it, when you cannot express it in numbers, your knowledge is of a meager and unsatisfactory kind. And so for any of you that have gone to trial and sort of fighting over, what a photograph might have shown or something like that, it's a much safer place to be in when you're discussing things like, I took a measurement or I have a measurement, I can do an analysis for something like that. So for me, this is a really important quote and something that I sort of try to work to in my own work. And that is the last slide that I have. And so what I'm going to do now is just look at the, I'm going to stop sharing here for a second. And I'm going to look at the chat window and I'm going to try and answer some questions. So let me just close some things here. All right, let me see. Okay, there's people from Calgary. There's Yahaya. Hey, how you doing? Welcome, welcome. Tyler. Okay, what's the difference in actually affect the outcome in court? Okay, so yeah, we can talk about admissibility. There's a lot there. And it really depends on what you're using the data for. So for example, if you're doing an analysis that's going to have some bearing or outcome on whether somebody's going to get charged or not, or going to go to prison or not, then that's more substantive. So it has a lot more weight and it's going to be under a lot more scrutiny. So accuracy would be more important. In the case of, hey, we've got a minor crash scene here. It's a civil matter. Nobody really got seriously hurt. There's some damages or something like that, whatever. And let me just do an animation here and I'll show you, what the scene looks like. Much less weight, right? Not as important. If the scan data is only accurate to a few inches, no big deal, right? You can see where the pole is. You can see where mostly everything is. It's to help people out. So admissibility is a big discussion. I could talk a little bit more about it, but I'm just going to move on here for a second, but I can come back to it if you like. You can just go ahead and type in the chat window if you want me to say more. There was another question. Oh, the name of the application I put in there already. Did I miss anything behind? No, I think that's good. Shubham. How do you get a certificate for attending any of my courses? Well, you got to attend the course first off. So if occasionally I host courses, but just look on the website and you'll see some of the courses there. If you sign up for some of them, that I'll be announcing some in the new year. There's none for the rest of the year, but there will be some for next year. And if you sign up, you'll get an email on it, and then you can decide to sign up. If you take the course, you attend, you complete all the assignments, then you can get that. If you mean for this talk, this is not a certificate talk. This is freely open. It's available to everybody, but there's no certificate for listening. You had another question on how do we recreate the crime scene post destruction. Well, if you mean after, I'm not sure exactly what you mean there, where it's post destruction. If it's been destroyed and you haven't documented it, then that's a problem. But really, if you're able to laser scan something, you can always, because you have a virtual copy of it, and so you can do some things there. Now, if you have photographs and the scene is no longer the same, or it's been changed, or something's been destroyed, sometimes there's ways to use photogrammetry, or there's ways to use the photographs to reconstruct and take measurements and things like that. Could the analysis of boxes in the blood study result in behavior analysis? Well, that I don't know. I'm not sure. Behavior analysis is not my area of expertise, and so maybe it will. I don't know. If somebody can say something about how violently or how many swings or something like that, maybe that can say something. So I'm not really sure. Let me see here. With limited digital evidence or data, 3D forensics can still bring hope. Well, Yahaya, yeah, for sure. I think the benefit here is that the technologies are becoming more available, and I can tell you that if it's sitting on your phone and people can, now don't get me wrong, an iPhone is not a cheap phone. Believe me, I know, but as more and more of these technologies become, on the order of a couple $1,000s instead of, 70,000 or 50,000 or 40,000, so for example, something like this here, the sensor itself is on the order of, a few $100s US, like maybe $300 US. And so there's different software that you can buy online. Some are a few $100s and some are a couple, maybe $1,000 or something like this. And that could potentially help you as well. Okay, Bell is asking me a question, not about 3D technology, but how do I find the guest speakers? Some are people who I've known for a long time, and some are just through contacts that I have or searches on the internet. Sometimes I find interesting research papers and things like that. And then what I do is I go ahead and find some more people, or I'll reach out to them, see if I can get a hold of them and see if they're interested in speaking. And I'm glad to say everybody who I've spoken with has been very kind and has been able to come on and speak to me. So that's been really, really great, really wonderful. So any more questions? I don't see any more real questions. There was a question about admissibility. Did somebody want me to speak to admissibility? I can make a few points there if you're interested, and what some of the key points might be if you're going to be using 3D technologies at trial. That could be another video, though. I don't know. Maybe I'll talk about it that way. Let's see here. Yahaya has another comment here. You've watched a movie where a photograph was recreated even after it had been burnt. Is that available technology or just one of the industry's anticipations? Yeah, I'm not sure about that. I'm not sure if once it's burned, I haven't heard of anyone. If the degree of being burned is maybe not severe, there may be some ways to recover some of the photograph, maybe using some alternate ultraviolet or infrared or some other wavelength. But I don't know of anyone that sort of can reconstruct the photo right back to its original form. So, you know what I'm going to do? I'm going to leave it at that. That's plenty for today. That's that's about an hour here. That's even over an hour. So I think I've spoken enough. And look, I've had a good group here today. So hey, listen, I want to say thank you to everybody that's been watching. There's some people who have been coming back that are like regulars here. So thank you very much for coming up every time and showing up and keeping in contact and posting comments and everything else. I do want to reiterate, though, don't forget about the IAFSM conference that's going to be coming up, and that's iafsm.org. If you're interested, have a look. Remember, there's the basic laser scanner certification course, and there's also the mass casualty exercise, which I think is going to be really, really great. And hopefully we'll hear more on that with respect to what's being organized and that sort of thing. But I just know it's a big group of people, a lot of teams that are going to be out there, a lot of participation from schools and from police agencies. So I think it's going to work out really, really well. Also, the Forensic Photography Symposium. Okay, so don't forget that January 17th to 20th. If you're interested, go to the website. The website is right here. I'll bring that up. Okay, and if you go there, it has all the information. I just posted the new schedule today, so you can see the whole list of speakers that are going to be there talking about how to document evidence with a digital camera. Topics like crash scene, using a pole, cross polarization, photographing at autopsies, infrared, UV, just a whole bunch of different things, including stuff on Photoshop, witness perspectives, all kinds of different things. So I think it's going to be a really, really interesting 4 days, and a lot of content. And so far, like I said, I'm really, really pleased with the type of feedback that I'm getting on this. So I think we're going to leave it at that, folks. Thank you very, very much. I really appreciate all your attention and your time. I wish you all a wonderful day, and we'll see you next time on episode 51 for Forensics Talks. So take care. Bye-bye.